Hey everybody, this is 7.3 Power Functions and Function Operations, Part 1. So now with 7.3 we're going to apply what we learned with exponent rules and radical rules to some situations, and our goal with this section is to add, subtract, multiply, and divide different functions. Just a quick little remembrance of some past math facts that you guys should know with our warm-up today. So why don't you pause the video and go ahead and try 1, 2, and 3 here for the warm-up. Alright, check your answers. For the first one you should have 4x cubed plus 4x. We just distributed the 4x. And for the second one, watch out, because remember, if there is a plus or minus sign in the parentheses, you can't distribute the exponent. Instead, we have to write it out twice and FOIL it. So the correct answer is x squared minus 4x plus 4. And then last but not least, here I'm hoping you'll remember to distribute the negative there. And so our final answer ends up being 4x minus 6. Alright, review from Geometry 2. A function. A function is a relation in which every input has exactly one output. Every input has exactly one output. Another way we could say that is every domain has exactly one range. And just a quick reminder, domain or the input is x and the range or the output is y. So a function, every input has only one output, and then with our adding and subtracting we're going to be talking about how to find the domain of some of these. And just to review, remember the domain or the input, they're just the possible x values we could use in the function. And function notation uses a f of x, it's called, instead of y. Alright, so first we're going to add or subtract these functions. So function can come in many different forms. Here's two examples. When it says find f of x plus g of x, we're actually just going to literally add these. And this is where your exponent knowledge comes in from section 7.1 and 7.2. So we're just going to add it. That's it. These have the same base, or not the same base, I guess, but I should say the same variable. Same base, same exponent. I don't know. 2 plus negative 6 is negative 4. And then one thing you should think about, this would be the correct answer, but also remember a 1/2 power is the square root of x. We are also supposed to right now find the domain. So we just added or subtracted the function. Here's our answer, either one of these, and now we're going to find the domain. So that just means the possible values we could use. The possible values we could use for x. So we just have to think about this a little bit. If I think about just kind of some math facts here, if I have a square root of x, I can't have any negatives for x because we can't take the square root of a negative. We'll get imaginary numbers. And another math fact, we can't have x on bottom of a fraction because that makes we can't have 0 on the bottom of a fraction because that makes it undefined. So those are kind of the two main things you're looking for, and I'll say more as we go along. In this situation, I do have a square root of x, so x can't be negative. X could be 0, so here's what I'll say. I'll say that the domain is x is greater than or equal to 0. Alright, now let's subtract these functions. So same exact thing we just did, only with a subtract sign in the middle. And I have a double subtract here, so it actually kind of turns into plus. So 8x to the 1/2 is my answer, and this one still has, really, it's a square root of x. So my domain again, and we can abbreviate that d. If you say d, you'll know what you mean. X is greater than or equal to 0 for the domain. Alright, pause the video and try part B. If you've unpaused, let's check your work. We should have 5x to the 1/3 for your answer for this one, and we should have just x to the 1/3 for our answer for this one. And I want to talk about the domain a little bit though, because there's something, well, you should just know a 1/3 exponent is the cubed root of x, and remember from what we've been talking about in class, we can have a cubed root of x because if I, like, quick side note, try to do the cubed root of -8, for example, or something, it is possible because -2 multiplied by itself 3 times would give us -8. So if I have a cube root of x, I can have negatives, I can have 0, and I can have positives. I can have anything. So I'm going to say that my domain is all real numbers. And it's fine with me if you just say all reals. So my domain is all reals for both of these ones. In general, you'll see me talk about this a little bit, but if you have a even root, like a square root or a fourth root, can't have negatives. If you have an odd root, like a third root or a fifth root or a seventh root, you can have negatives underneath. Moving right along, now we're going to multiply and divide the functions. So what they're going to do is they're going to give us two different functions. We're going to multiply them using some more of our exponent properties here. So now I have my function f of x, I'll fill it in. My function g of x, I'll fill it in. And now you just have to remember our exponent properties. So if I just have a regular x, really it's x to the first. So I'm going to use that exponent property where I'm going to add the power of 1 plus the power of 1/4. So in my mind I'm thinking, okay, 1 plus 1/4, 1 is the same thing as 4/4. Okay, so that's 5/4 total. So 3x to the 5/4 is my answer when I multiply. Now we got to talk about the domain. So here is where your knowledge of changing from a fractional exponent to a radical is going to come into play. Just a quick remembrance, the bottom number is the root number. The top number is the power, and you could write it like this, or I could write it like this. But either way, you can see we have an even root. Remember what I just said? We can't have a negative underneath an even root. Not possible, we get an imaginary number. So my domain, for example, 2a is x is greater than or equal to 0 again. We can't have any negatives. Now let's do some dividing with those same functions. I'm going to now have 3x divided by x to the 1/4. And remember exponent properties here, I do top subtract bottom, 1 subtract 1/4 for my new power. And 1 subtract 1/4 is 3/4. So I've got 3x to the 3/4. And that, if I convert it, now that would be a fine answer, okay, but if I convert it so that I can more easily think about what my root can be or not, I again have an even root. So I can't have any negatives for x. And then I need to teach you something right now, which I have not yet mentioned. In this situation, at this point at the end of the problem, I don't have a fraction anymore, so you might be thinking that 0 would be okay, but it actually just so happens that if you go throughout your problem, and if at any point within the problem there is an x on bottom of a fraction, that means that we can't have 0 there. So what I got to think about in my mind, what would I put on bottom to make that 0? In this situation it'd just be 0. So I can't have a 0 here at the beginning of the problem, which means we can't have a 0 anywhere throughout the problem. So in this situation, watch closely, I can't have 0 and I can't have negatives, so my domain is actually just x is greater than 0. Not greater than or equal to, but just greater than, because it can't be 0. Please pause the video and try part B. If you have unpaused, let's quickly check your work. You may have used your calculator if needed to add those fractions together, but I end up with 4x to the 5/6 power. And when you convert that to a fraction, or not a fraction I guess, when you convert from a fraction to a radical, you get an even root again, so my domain cannot have negatives. 0 is okay, because I don't have anything on bottom of a fraction. And let's check our answer for the second part of that. When you subtract those exponents, you should end up with 1 over x to the 1/6 power. And this one's a little bit more clear this time. Can't have 0 on bottom of a fraction, so x can't be 0. X can't be negative because we can't have a negative under a even root. So this time the domain is just x is greater than 0. Only positives, no negatives.